Hello, as part of the crane operation, I am going to explain in this video you are going using different slings, shackles. So in this video, I am going to discuss about the slings. Lifting capacity depends on what arrangements it depends, because if it is a different angle, can its lifting capacity or the maybe for example a 10 ton or 6 ton slings you are using, but at what angle you are using, so it that decides its actual lifting capacity at that configuration. So we will explain how slings lifting capacity depends on rigging arrangements. So understanding the critical relationship between rigging configuration and lifting capacity is essential for safe and efficient material handling operations. My name is MS Akhtar. I have 35 years of Middle East experience, and I have just retired, and I started sharing my knowledge and experiences so that you become a competent HSE professional. So let us start this video. So the fundamental of lift sling capacity is depends on the hitch type matters. Hitch means what arrangements you are making. Vertical, straight it is, or choker you are lifting it, choke you are doing. For example, one you are putting it inside the eye, and basket configuration. I will explain. Each provide different capacity rating based on load distribution pattern. So angle is critical. At what angle it is used? First I have explained what it is, single or choker hitch or basket, and at what angle it is used. Sling angle dramatically affect load limits. As angle decreases, tension in the slings increases exponentially. Okay, so there are two factors you understand now: the hitch type and the angle. The real world impact: a 500-pound rated sling can safely handle 1,000 pound in a 90-degree basket hitch. Four slings if you are reaching basket hitch, demonstrating configuration importance. So now you understand the hitch. Vertical hitch is, you are seeing this here in the photographs. What is the vertical hitch? The most straightforward configuration utilizing full sling capacity at 100%. Yani, if you are using vertical, then it is you are using a 100% rating capacity. For example, 6 ton only lift the 6 ton if it is vertically lifted. Choker hitch, if capacity reduces to approximately 75%. Same sling, if you are using in a choke arrangement, it can approximately 75% due to stress concentration at the choke point. Okay, where the sling wraps around itself. Okay, and the third arrangement is basket hitch, means can provide up to 200% capacity at 90% angle. Means four angles you are using at a basket. If you are using the same angle, 6 ton capacity, you can lift it as a, how much? It is 18 tons, correct? But effectively decrease significantly as sling angle become more accurate, more acute. For example, it depends on the angle also. I am telling about the basket hitch, I am going to explain. But if angles varies, that capacity also reduces. In this slide, I am explaining the critical role of sling angle. See, if it is 60%, if it's 60-degree, recommended minimum, multiply capacity by 0.866 factor. 60% if you are using. 45% if you are using, it is 0.707. It means you 8 ton or 6 ton slings, you have to multiply with, if you are using at 60%, you have to multiply with this. Okay, 0.866. If it is 45 degree, that angle of the of the slings, you have to 0.707. If it is 30 degree, then it is just half, 0.5. Sling angle is measured between a sling leg and the horizontal plane. This angle decreases, tension increases dramatically, creating dangerous loading condition. Okay, so you have to remember these things. Now calculating working load limit. So vertical working load limit into number of legs, yani how many slings you have to making the legs. Then the single sling angle factor equal to adjusted WLL. That is a simple formula. Determine base capacity. Start with the vertical working load limit of your sling material and sizes. Count active legs. Identify how many slings legs will share the load. Chain sling, use 3 legs maximum to calculating. In calculating, apply angle factor, multiply by the appropriate sling single leg factor based on your rigging configuration. Okay. So practical example is 500-pound vertical WLL, yani working load limit, into 2 legs into 0.866, because it is at a 60 degree, then it is 866 pound effective lifting capacity. Okay. So you have to remember this. Now, visualizing the angle effect on capacity. If it is 90 degree, 100%, I have explained already. If it is 60%, it is 87%. If it is 45 degree, then it is 71%. So this is the question of the interview also. We may use to ask, if it is 30 degree, then it is exactly half of the capacity. So this visualization demonstrates how sling tension increases exponentially as angle decreases, creating potential dangerous loading condition that can lead to equipment failure. Now, just try to understand the multi-leg configuration and load distribution. Load balancing, it is a big challenge, balancing challenge. More legs increase theoretical capacity but require precise load distribution. Uneven loading can cause individual slings to exceed their limit at a particular lifting configuration. Hardware solution, master links, shackles and spread bar help maintain proper sling angle and ensure more even load distribution across multiple legs. So professional riggers understand that adding more slings does not automatically increase safety. Proper geometric and load sharing are paramount to successful lifting operation. So safety standard and regulatory compliance, 3:1 is the safety factor. A standard safety factor ensure braking strength is at least 3 times the working load limit for reliable operation. So 3 times. In some places it is 2.5 also safety factor, but in the lifting, in the slings, it is 3:1. Never exceed working load capacity. Working load limit must never be exceed in operational use regardless of higher braking strength rating. So this is the OSHA requirement is mandates secure attachment, load protection measurement and regular inspection schedule for all lifting equipment. So this is a mandatory requirement. So learning from real world failure, the incident has happened. Sling failure occurred during routine lifting operation when rigging was configured at a 25 degree, creating excessive tension. Because as I have explained, as the angle reduces, that angle, the tension increase and the capacity of the sling reduces. So root causes: inadequate sling angle create tension load exceeding the working limit despite the load between being within the sling's theoretical capacity. This is 6 ton and it is lifting only 2 ton, but it can break. So lesson learned, always maintain sling angle above 30 degree, preferably in the 45 to 60 degree range. Proper planning prevent accident and equipment. So key takeaway from this video is proper rigging geometry is just as important as selecting the right equipment for safe lifting operations. Thank you for watching this video. My name is MS Akhtar. Please subscribe my channel, like and give your comments. Thank you so that I can prepare more video which you need.